Ladies and gentlemen, distinguished guests, good afternoon. And thank you all for joining us today for this 35th edition of the Audiokinetic Wise Tour. It's a pleasure to have you here today. Before we start, I would like to contextualize this event in space and in time to remind us why this Wise Tour is so special. Our vision at Audiokinetic is a well where audio creator can channel creation without limitation. From the beginning, it was crystal clear that in order to achieve this vision, we needed not only to build the best cutting-edge technology, but also to be closer as much as we can to our community. We aspire to provide a platform where we can all share ideas together, to learn from one another and to support each other. The Wise Tour was one of the first commitments along this path. The first Wise Tour actually took place here in Tokyo in 2007. Since then, we've traveled the world, and today we can say that the Wise Tour is an internationally anticipated event. So now let's take a quick trip down memory lane before we talk about what's next. Audiokinetic was founded in 2000 in Montreal, Canada. And after several years of development, we released our first version of Wise in 2006. Also, the same year marks the first release of a game powered by Wise by Microsoft Studio. Knowing that Japan is one of the birthplace of video game, it was really important for us to get closer to the community and to make sure that we can actually reach all developers with our technology. After a few years of being successful, we established in 2013 our first subsidiary of Audiokinetic here in Tokyo, Japan, Audiokinetic KK. In 2014 was a big year for us. First of all, we reached an important milestone of 500 games powered by Wise. We also, the same year, Wise became an industry standard. And we also launched our educational program that has been growing since and we're extremely proud of. And the same year, we started to look into different segments towards diversification. 2015 and 2016 are also important because we've launched our initiative in the location-based entertainment and to automotive. And 2016, we actually, another milestone of 1,000 games powered by Wise. 2017 and 18 actually mark the release of our first demo car in collaboration with Continental that were presented at the Consumer Electronics Show in Las Vegas. As you know, in 2019, we've been acquired by Sony Interactive Entertainment. We choose the Sony Group because it's the best partner for us towards our future goal. And I want to reassure you on one thing is that it was clear from the beginning that we needed to stay independent and neutral. And Sony Group did not hesitate to endorse that condition. Wise is a cross-platform solution, first, foremost, and forever. 2020 actually marked a second demo car in collaboration with Sony that was unveiled at CES, Vision S. And the same year, actually, we opened our second subsidiary in Shanghai, China, called Audiokinetic Shanghai Technology. In 2021, can you believe that Wise went to the Super Bowl? Yes, the entire NFL season and the Super Bowl were powered by Wise. So in 2022, we launched our second standalone product called Strata. Strata is actually a paradigm shift in the world of audio libraries. If you haven't had the chance to look at it, please take a peek because it's really very interesting. In 2023, we actually opened our European subsidiary based in Hilversum, the Netherlands. It's called Audiokinetic BV. And all that was put in motion because of Wise, because of you, the community. So here's a small GIF of the growth of our community in the past 5 years around the world. You can see actually the year there of the growth. Let me give you some interesting stat about our ecosystem. There is around the world more than 250,000 Wise users. And we have over 45,000 students around the world with 475 institutions teaching with Wise. And since the beginning, we've published over 1,200 blogs in 5 languages. Because everything we do is actually in 5 languages. Let me give you some stats of Japan. We have more than 9,000 users. Thank you, everyone. And we have over 2,300 students. And we're dealing with 87 developers in Japan. Thank you. So let's look at the different segments in which we are operating. For sure, gaming has been our primary market, and it will always stay close to our heart. There's also, we started into location-based entertainment. Unfortunately, during COVID, they had a hard stop, but they're back. And it's really a growing and very interesting segment for interactivity. And we've been also in the automotive segment, playing on 2 sides, with infotainment and safety issues in cars. In automotive, through our collaboration with Sony and Honda Mobility, it was unveiled this year that they're releasing for 2026 in production a car called Afila that is powered by Wise. And lately, Shanghan Motor in China actually is releasing its first car in production for 2024 powered by Wise, the Shanghan 701 model. So I just spoke a bit of all the different offices that we have around the world. And Tokyo today is very special for us because if you remember, I said that it was founded in 2013. So I'm extremely pleased and grateful today to be with all of you to celebrate the 10 years anniversary of Audiokinetic KK. Thank you all. It's really, really, really a pleasure. Yeah. Thank you. I missed that one. But I would like to thank a few people, and if you allow me, I'll just take a list, because I don't want to miss any name. So, our success is due to you, user, developers, and partner, the community. You have trusted us and support us, and have been loyal friends. For this, we are extremely grateful, and we thank you. On this special event today, I would also like to thank Stéphane Beaulieu and Duncan Wright, who were part of the Canadian Embassy then in Tokyo, for their amazing collaboration in the inception of Audiokinetic. An immense thank you to the people at JETRO, Japan External Trade Organization, to Bruce Darrington at Mazar and the team at Morrison Foster for their cooperation and support in establishing a subsidiary here in Japan 10 years ago. I would also like to thank the team at Akiya Tax Consultant for their long-time support, advice, and teamwork with Audiokinetic KK. To Masato Tajima for giving us 10 years of commitment. Thank you. And to Masato Usujima, I'm sorry, for being a remarkable product expert. Thank you. And lastly, I would like to thank our amazing team here in Japan for their dedication and artwork in the success of Audiokinetic. Thank you all. And I wish you really an amazing Wise tour today. So now I would like to introduce a longtime collaborator and co-founder at Audiokinetic, our CTO, Martin Dufour, who will share with you a presentation on loudness measurement and normalization. Have a good show. Thank you.
Hello, my name is Martin Dufour, the Chief Technology Officer at Audiokinetic, and today I'm here to talk about loudness, measurement, and normalization. Since we've recently improved the normalization features in Wwise, I thought it would be a good time to review the full feature set and the reasoning behind it. So I'm going to go through loudness measurement in general, then look at how loudness is used in Wwise, including the new features, and finally show two examples of automated workflows using WACL, Python, and WAPI. So what we call loudness is the measure of perceived sound intensity, specifically for the human ear. This is a subjective measure, different from objective sound pressure level. There are physical and psychological aspects that come into play. One of the characteristics is that for a sound at a given sound pressure level, we will perceive a different loudness based on the frequency. So on the equal loudness contour curves here, you can see how we are particularly sensitive to sounds in the 2 to 3 kilohertz range. And it's also clear that a low frequency sound needs a lot more power to be perceived as loud. There are many other factors to take into account, and it's still an active area of research. But for now, the professional audio world has settled on the ITU BS 1770 standard as the way to measure loudness for mastering content. There's much value in using a well-understood metric that's familiar to many. So the loudness computed using this standard is known as LUFS, or sometimes LKFS, and it uses a decibel scale. Here's how it works from a signal standpoint. First, we apply a frequency filter that represents the perceptual curve from the previous slide. Then we compute the RMS of the signal. For multi-channel content, a spatial weighting is applied so that channels to the side are assumed to be slightly louder than what's in front, rear, or above. And finally, we average this measure over a certain period of time. The standard has 3 time periods: momentary, short-term, and integrated, varying from 0.4 seconds to the entire length of the piece of content being measured. In this last case, some gating is also applied to discard the most quiet parts of the measurement. This ITU standard was originally developed for broadcast television as a result of the so-called loudness wars. When peak metering was used to control the levels, there ended up being an overuse of compressors and limiters to make content louder than other content while remaining under the peak limit. When directly controlling for loudness, content with good dynamic range is promoted, and the audience gets a better, more consistent experience. So this standard is now widely used. with recommendations varying based on platform and type. Television has settled on targets of -23, -24 integrated LUFS, depending on the region, with some extra margin for variance in the case of live content because of its less predictable nature. In the case of streaming services such as YouTube and Spotify, -14 LUFS has somewhat become the norm. In gaming, the standard also is used in the same way. For example, PlayStation recommends -24 LUFS integrated, same as broadcast TV, but with greater tolerance for variance due to the nonlinear nature of games. Now, in games, it's also relevant to consider input side loudness at the asset level as a pre-mixing pass. I found a great example of that in a recent talk from the folks at CD Projekt, where they detailed an automatic normalization process for lines of dialogue based on their type, from whisper to shout. This ensures that any new content finds the right place in the mix with as little manual intervention as possible. Now let's talk a bit about Wwise. Wwise is a loudness meter that follows the standard. It produces data for all three timescales and can graph their value over time when capturing data, whether locally in authoring or when connected to a game. It's got a number of configuration settings that allow to customize the display for different recommendations. And when we rolled out object-based mixing in 21.1, we didn't have support for the loudness meter on object buses, but that's something that we've added in 22.1. I mentioned pre-mixing of assets. Wwise has also supported that for a while. You can enable loudness normalization from the conversion tab. This takes the integrated loudness measurement of your sound assets and applies a runtime gain so that the resulting level is -23 LUFS. This is a non-destructive runtime gain, so it does not affect the quality of the asset during audio file conversion or introduce clipping, unlike normalization done directly on the WAV file in a sound editor, for example. I think that's an overlooked benefit of using this feature from Wwise. The effective gain being applied can be seen in the voice inspector. Now, integrated loudness is a great tool for measuring full-length content, but it turns out it's not the best for short-duration sound effects. This slide here is an example of that. Here we compare two short sounds. At the top, a simple 400 milliseconds noise burst. At the bottom is the same noise with reverb added, so that its duration is about 1.5 seconds. The one with the reverb is measured quite a bit lower in terms of loudness, because the integrated measure takes the average over the longer period of time, and most of that is during the reverb portion. In reality, those sound about equal in terms of loudness, with our perception entirely determined by the initial burst. So how do we improve this? It turns out that momentary max is a better fit for this type of sound. That is, we measure momentary loudness and pick the highest value over the duration of the sound. Using momentary max means that we will classify the sound according to the highest point. In the ITU standard, momentary uses a 400 millisecond window. In Wwise, specifically for normalization, we opted for a shorter 100 millisecond window. This solves issues with very short sounds that are quite common in game. This is consistent with research on loudness, which indicates that the loudness of a sound starts to rapidly decrease with durations below 100 milliseconds. So for Wwise 23.1, we made a few additions that I feel greatly increase the usefulness of the normalization feature. We made the target explicit and configurable. It defaults to -23 for backward compatibility, but you can choose a value that matches the type of content and its desired position in the mix. We added the momentary max measurement type. Apart from short sound effects, I'm sure we'll find more scenarios where it's a better choice than integrated. Finally, Wwise computes loudness for every original asset, even when not using normalization. You'll find loudness as a new field in a list view, and this measure is available in WACL queries and via WAPI scripting. Here's an example of the WACL feature in action. Let's say you have defined a loudness standard for dialog assets, and you want to find all assets in a Wwise project that are not mastered within a given loudness range. We can build a WACL query for that using the loudness accessors. This one is fairly simple, as you see below. From the dialogues work unit in the project, select every descendant where loudness is in the range -10 to -4. So, demo time. So here, I'm going to quickly copy this query. And there's a number of places where I can put this WACL query. In the Project Explorer, for example, if I write that query, the results would be filtered and highlighted in yellow. Another place where we can use this query is the query editor. And it opens in the other screen. Right. So in the query editor, what's interesting is that the query that I enter will become part of the project for easy reuse. So here I can run the query, and we see the results in the bottom part of the screen. We can also configure the columns so that it's easy to actually see the loudness of those outliers that were found in the project. Going back to the presentation. So I have another scenario that involves normalization. Let's say I bring in a group of sounds to create a container. I want each one to be at the same loudness so that it works consistently in the mix. But I just want the target loudness to be the average of the group. That's not a specific feature that we've added to Wwise, but we can create a custom command for it. Let's see the command in action. In this project, I have a, actually we'll open the list view. There's some footsteps that we will be able to find using the search field here. Let's say dirt, right. So I've got one container with 4 sounds in it. If I right-click on the context menu, there's an option that's not normally there. That's my custom command that I've added. If I click on it, it will execute a script that performs an operation on the current selection. So let me just do that. And yes, it worked. So this changed the loudness normalization of the selection to be the average value of the loudness within the container. So how does that work? Wwise has the ability to look at a few folders on the file system where you can drop files that describe those commands, such as the one that you saw. In this case, it executes Python, passing in a script that is in the same directory, and will also pass IDs for the currently selected objects. The script itself is about a page or 2 of Python code. We won't go through that. But it uses simple WAPI methods for getting and setting the value of properties. I'll be sharing this example soon, so you can have a good look at it. And I hope it's giving you some ideas already of how you can extend Wwise with custom commands. In conclusion, I think it's fair to say that loudness is a useful metric, that automatic normalization can save much time when mixing large-scale projects, And I hope you like those new features. As always, let me know what you think. That's the end of my presentation, but if you want to know more, here's a few links where you can learn more about Loudness. Check it out, and thank you.
Minasan, konnichiwa. Watashi wa Dr. Alexander Horowitz. Yoroshiku onegai shimasu. Good afternoon. My name is Dr. Alexander Horowitz. I am the audio director at Improbable, a games and technology company based in London, England. I've been invited here today to talk to you about my findings from working on large-scale projects. That is, projects that have large budgets, large amounts of team members, and also are being made over a long period of time. Firstly, I'd just like to say it's a great honor to be here. This is my first time in Japan, but for a long time I've admired the technological and especially the game development contributions that Japan has made worldwide, so thank you. I'd also like to thank Audiokinetic as well for bringing me here today, for two reasons. Firstly, I get to speak about a piece of software which I really enjoy using. It's very easy for me to talk to you about Wwise because I love using it as a piece of software. Secondly, it's fantastic to get to speak to a room full of people here who are as passionate about game audio and interactive audio than I am, so thank you very much. So what we're going to talk about today are three things: optimization, project management, and to some extent, people management as well. So we'll be looking at three different areas, all focused around Wwise, all looking at Wwise as the central point and the place where we can make our changes to the project. And what I'm not going to do is go into a detailed technical view. I want to get a holistic view, an overarching view of my experiences from projects in the past. So I just wanted to give you a bit of background about me. I've been an audio lead or an audio director or a head of audio for around 8 years now. And I've worked on projects like the ones on the right-hand side of the screen here for publishers like Warner Brothers, Rockstar North, Fox, and Electronic Arts as well. My training, I did my PhD in game development at the Glasgow School of Art in Scotland. And I did my two master's degrees, one in technical broadcast audio and the other in games programming. My background is as a composer. So I went to a conservatoire in Scotland as well, a music school, and I wrote string quartets and for clarinet and piano and for opera singers. So really I'm between the worlds of creative audio and technical audio. Most recently, I was the audio lead at Studio Gobo in England, working on Hogwarts Legacy. And that was 5 years I was working on Hogwarts Legacy for, and I was directing the European audio team there. I also did some composition work as well, and that score has been recently nominated for a Grammy, which we're really excited about. So that's a bit about my background. Let's talk about optimization for AAA projects then, for large-scale projects. And there are four areas I really want to look at here: memory, disk space, CPU, processing power, and streaming budget. And I want to unpack each one of these in turn and have a look at some of the things that we can do in Wwise to make sure we're staying on track and we're doing the right things for the project. When we come to memory and disk space, one of the first things I like to do with the project is to establish some placeholders, some temporary assets that we can use and we can start to replace as the project goes forward. So one of the things I want to try to do is establish an estimate for how much data we might use over the course of the project. And you might say to me, well, how do you know which assets you need before you design the game? But my argument would be, well, we know which game we're making, we know the genre, we know how big the game is, we know the budget roughly, we also know how long we have to make it, generally speaking, and we know who's making it. So we can start to think how much data is going to be here, how much can we add temporary assets in and start to replace them later. Now, some of the areas we may do that would be things like ambiences, dialogue, and music. And so for 2D and 3D ambiences, we might say, well, we don't know exactly what those ambience files will be, but we do know how many levels we might have. We know how many areas we might have. Maybe there's a forest, maybe there's a cave, maybe there's a city. So we can start to build up a rough idea of that estimate of how many assets we might need for that area. And that's both the 2D stereo assets as well as the 3D mono assets that are positioned in 3D space that have distance attenuation and spatialization. And when we start to get a duration of that, that starts to add up to a data size, not just on disk, but also in memory as well. We can say how much memory is required by each level, how much memory is required by each area of an open world map, for instance. With dialogue, we don't know what the lines of dialogue are. When we start making a game, we haven't written the dialogue yet. But we do know how many characters there might be, and we definitely know the budget that we have to record those lines of dialogue. So what that does, we can start to get an idea of how many lines might be in the project. And that starts to give us a better idea of the disk space required as well. When it comes to music, again, when you start a project, you don't know what the music's going to be straight away. You might have an idea, it's for a rock band, it's for an orchestra, it's jazz music, but you don't know how many tracks, you don't know how many different stems those tracks are broken up into, but you do know your budget for paying composers, and you do know how much time you have to record that music. So that starts to give us an idea of how much space we might need. This screenshot on the left here shows what happens if you have too many footstep assets in a project. There are the left foot walking on snow has 360 gigabytes. If you've put that much data in your project, you've gone way too far and start to step back, okay? The next thing I like to do is to start managing expectations of the team and of people like technical directors. So one thing I like to do is to ring fence space, that's the term here. Can we start to carve out some space on the disk and in memory that we can use later on and fill up? And my diagram here, instead of starting at Vorbis level 4 and trying to increase that later on, start high. Start at 9 or 10 perhaps, and bring that down slowly over time. Now, I'm not suggesting you lie to your technical directors, that's a really bad idea. But I do think we should be realistic about the quality of the assets we want in the project. We shouldn't try the bare minimum. We need to try and have good sounding assets and then make it fit on the console. Another thing is sample rate optimization. And I've seen quite a lot of people's projects before where they've forgotten to use sample rate optimization. It's a very common feature. It's something that's done really well in Wwise. But sample rate optimization can make considerable savings on the data size of your assets. So this screenshot on the left here shows the different decibel values for low, medium, and high quality. And one of the first things I do with a project is go in and set those values. That FFT window size, that's measuring how frequently we take images of the waveform, essentially. But the decibel thresholds, I like to think about not as low, medium, and high quality, but as platforms. So the high quality, I equate to generation 9. That is PlayStation 5, Xbox X. Medium quality, I might equate to generation 8. The 8th generation of consoles being Xbox One and PlayStation 4. maybe switch goes on low quality. So we can start to think about dividing up our assets, not just based on how important they are to the project, but also about platform as well. And then this middle screenshot, we apply those settings, we generate those new converted assets, and on the far right there, we've gone from 48,000 hertz sample rate to 6,000. We've made a considerable saving just from using sample rate optimization. So it's something definitely worth playing around with to see how far we can push sample rate optimization in a project. Here are some build times, how long it might take to actually do that sample rate optimization. And one of the concerns people have is how much time will it take to generate those builds? And what I would say from my experience of trying to build this on a single machine, on my workstation, is that it took longer, but not considerably so. So the orange-yellow box at the top there shows about 10 minutes to build. And in the blue, for different FFT window sizes, it took an extra 60% of time. It's not that long to actually build these things. The next thing I like to look at, and we looked at queries before, was actually using queries to help us reduce asset sizes. When we have a large AAA project, something like Hogwarts Legacy, we're putting lots of assets into the project. And so what can happen sometimes is, not through anyone's fault in particular, but team members can forget to change configurations of channels. They can maybe put assets in that are too long for the project. What we can do is we can look for, say, 7.1 assets in the project using a query that looks at channel configuration. And we can say, do we really need 7.1 assets in the project? Maybe 5.1 is the most we have. Maybe we're using quad assets, 4-channel assets. What we can also do is things like dialogue. Most of the dialogue that I work with is mono, it's one channel. But what can happen sometimes if we're dealing with lots of dialogue is we can end up having additional channels by mistake. Maybe things come in stereo. I've seen in cases 5.1 dialogue assets, and all they were was the same file copied onto every track of the 5.1 asset. So using these channel configuration queries, we can start to actually find problem assets in the project. Trimming media down as well. Sometimes I've seen 15-minute ambiences, 30-minute ambiences, never 2 hours, that's an exaggeration perhaps. But I've seen long assets there which don't need to be there. So what we can do, rather than going into the actor mixer hierarchy and manually looking for these assets, use a query and set these queries up as you're getting started. When you start the project, this is one of the first things you can do. Here are some of the queries that I tend to establish on projects. On the left-hand side, these are for channel configurations. So they're looking for 3, 4, or 6 channels, 5, 7, 8 or more channels. If you have a 10-channel ambience in there, was that intentional? Was that a mistake? When you're working with a few thousand assets, this tends not to happen. When you're working with 100,000, 200,000 assets, or 1 million assets, it starts to become a problem. Dialogue 2+ there, dialogue that's over 2 or more channels. That's the thing I was talking about before. Tracks that have missing LFEs, that don't have that low subwoofer channel. So we can use these queries and create these straight away. And you can happily take this as a piece of information to take into your own projects if you're not doing so already. On the right-hand side, we have the source duration. How long is the asset? And so the first one looks at dialogue. Is dialogue over 30 seconds? Very few of the lines of dialogue in the projects I've worked on have long assets. We don't have 5-minute dialogue lines because we would split those lines up into individual parts. music that's over 5 minutes, things that aren't music that are 2 minutes or more, or that are 5 minutes or more. So we start to end up with a way of checking durations very easily at a centralized place in the project. Looking at memory and disk space as well, we can look at streaming. Do we even need to load the entire project into memory? Can we stream assets? Now, we should be streaming assets generally, and things like dialogue and music and long ambiances, we typically would stream. But we can think about actually potentially loading everything into memory. And that's something we'll talk about later in the context of Generation 9. CPU. There is a page on Audiokinetic's website called Conversion Tips and Best Practices. And this is what it looks like. And this is probably the most important page, at least that I use, other than the forgot password page that I seem to be on every single week. This is talking about PCM and Vorbis and other codecs. And it talks about the processing cost versus the memory cost of those codecs. And if you're not familiar with this already, make sure that you are. Go and have a look at this piece of documentation. I've put the link on there, and you can go and see what's going on, because it talks about the balance between CPU and memory between different codecs. And this is really important when we come to optimize for either CPU or memory later on. Looking at memory there, variations. I tend to keep variations to about 6. So I have a random container on the left-hand side there. It has my variations for different sounds in, and I tend to use around 6. Sometimes more, if you have a project that has a very important main weapon, maybe a sword that's a really special sword that the character uses, you might put more detail in there. If you have a very particular type of transport, maybe a horse, and you want to get the footsteps sounding really not just accurate, but having lots of variation, then you might put more. But 6 seems to be around about average, and that helps us stop bloating the memory and the disk space of the project. For CPU, things like effects rendering. If you're not rendering your effects already, you really should be. The only time when you shouldn't render your effects is when you want to control the variables of those effects using RTPCs. And so on the right-hand side at the bottom, this is the simple tick box for rendering. And so what you can actually do, you can use the integrity report that's built into Wwise, or you can create your own query, which then actually looks for any effects that haven't been rendered. The difference between using the built-in integrity report, which is really good, and using your own query is the query can be more specific and tailored to your project. Streaming budget. Looking at the limits of streaming. How much can we stream? This diagram talks about PlayStation 4 and PlayStation 5. These are the bandwidth, the seek time, and the load time of the PlayStation 4's hard drive and the PlayStation 5's solid state drive. And in conclusion with it, what it basically is saying is the PlayStation 5 Generation 9 of consoles, that includes Xbox X, is better in bandwidth, in seek time, and in load time, meaning that it's much easier and quicker to get data off the disk. That lets us stream a lot more information. And that starts to make us think, can we stream more than just some dialogue and music? Can we stream sound effects? Can we stream all of our ambiances, even the shorter ones? And the thing to consider is, if we stream everything, the only thing we have to do is make sure that we cache the start of any files that need to be synced to animations or to particular game events. If we need music to play at the very first frame of a cinematic, we need to make sure that we have that data instantly rather than waiting for it to be streamed from the disk. So there's a consideration for streaming. With our CPU budget, if we're having problems with CPU, the processor is doing too much work, can we use PCM encoding? So what we're doing, coming back to that page on Audiokinetic's website, if we increase the proportion of PCM assets in the project, what we do is decrease the amount of CPU that's used, because we don't need to then decode the Vorbis files using CPU at runtime. The other way around, with memory, can we reduce the memory by using Vorbis? So there is a balance between CPU and memory. When you're optimizing your projects, it may be large-scale projects, it may be something smaller. You may find, especially with VR applications, that you have problems with CPU or memory quite soon on in the project. And what you might need to do is start to think, can I change the Vorbis quality settings? Can I have PCM for some very short assets? Maybe little UI sounds are PCM. They won't take up very much space, but then they won't contribute to the CPU hit either. So looking at memory, CPU, and streaming overall, if we want to reduce that impact on the memory, we can set more assets to stream, and we approach the streaming limit for that platform. And each platform is different. One of the first things that I also do on a project, and I did this when we were setting up Hogwarts, was I went into Boom Library and I sorted them by size. And I took the 64 largest files, very large files, about 500 megabytes each. And I brought them all into the project and I put them in the active mixer hierarchy and created one event that played all of them at the same time. It sounded terrible. It was just noise. But I set them all to stream. And I wanted to see what would happen if I had lots of streaming assets at once. And it depends on the platform. Some platforms will happily take that. Some will hit their streaming limits sooner. Try this out on the hardware you're using. Depends. Some of you might be developing for mobile as well, in which case you might hit that sooner, you might not. It really just depends on the project. To lower the CPU hit, we can start looking at PCM usage. We can use more streaming as well. So we can look at this balance, these levers we can pull between memory, streaming, and CPU. And this, what I've said in yellow here, we can maybe have all streamed assets. Just have a look at your platform. So let's have a look at team considerations then. People. We're all people, we're all working as teams or individuals on projects, and it's not just about the software and its features, it's about how we work together using those features. And so looking at work units and project architecture, how we set up our project to avoid complications in our teams. Work units don't cost anything. This is the big consideration here. There's no additional fee that goes to Audiokinetic if you use 1,000 work units or 10,000 work units. So my recommendation is always don't let yourself be trapped by not using enough work units. Don't let your team get in each other's way and block each other because you only have 5 work units in a project. And this isn't just in the actor mixer hierarchy, this is in events, sound banks, this could be in game parameters, in states, switches, share sets. All of these things where you can create more work units to let your team members share the project easier. This happens especially towards the end of a project. You might be mixing certain sections of a game, but people might still be trying to polish individual assets. If you have too few work units, it becomes very difficult for everyone to do that hard work at the same time. And you end up fighting over ownership of work units. Testing banks and debug sounds, I think is really important as well. When people are testing features, maybe they're testing blueprints in Unreal. Maybe they've set up a new blueprint and they want to test the functionality of that blueprint. What we can do is bring a sound into Wwise, set that up in the blueprint, and then when we've finished, don't save it. Just delete the asset that was brought in, and we know the blueprint works. The problem there is that every single time we have to set up a temporary sound, we're wasting time. We could refer to a stock bank of debug sounds, especially if we do that at the very start of the project and we communicate to the whole team that those sounds are there for anyone to use or to add to. So in this screenshot, I have a silent loop to test if an event is playing. I've got some sine tones, some white noise, and they're of different durations. Some are 5 seconds, 5,000 milliseconds. Some are loops. And you can expand this very far. You could carry on and have lots of different sounds, maybe dialogue, temporary dialogue. You could have music. It all depends on the project that you're making. Another thing is to give everyone their own place to experiment, their own sandbox, we might call it. Somewhere where people can go in, they can try things out and not break the main project. It's still within the same Wwise project, but it's in a separate work unit and a separate location to let people have fun, experiment, and try things out. So one of the first things I do when I start a project is to create a space. You can see mine in yellow there. But create a space for every person on the project where in the actor mixer hierarchy, but also in events, share sets, game syncs, people can try things out. And another thing that I try to do when projects get large, it can become very messy and very difficult to find things, especially with lots of people working on a project. If you have 15, 20, 25 people all contributing to the same Wwise project, you have to start being very strict about naming conventions and different formatting unless you want the project to turn into multiple strands. And one of the things that I try to do is make sure that the actor mixer hierarchy, the events, and the sound banks all have the same names. So we have the actor mixer work unit, has the same name as the event work unit, has the same name as the sound bank work unit, has the same name in the Unreal Engine content browser folder. So all the way through the pipeline, there is a continuity. There is a complete form all the way through that. Finally, I'd like to talk about moving from development through to post-production and finally shipping. What is our route to shipping this game in the end? Actually releasing this and getting the copy on the shelves. And specifically looking at the role of queries and what I call a shipping checklist, the ready to ship, ready to release checklist. One of the first things in queries is to make sure that the correct objects are streaming. We talked about streaming before. Streaming, very important. And if we're not using streaming, we can bloat our memory size. So we need to make sure that the correct objects are set to stream. So what we can do, I say here, music, dialogue, and generation 9, what we can do is set a query up that says, are all of the music files streaming? Are all of the dialogue files streaming? And if not, we want the query to tell us and warn us that we haven't done something. We haven't prepared the game for shipping yet. The next thing is setting effects to render. We talked about effects before. The integrity report does this already, but we might want this to only apply to sound effects, or only apply to dialogue, for example. We want to avoid effects that are being driven by RTPCs. Here's the integrity report, and again, this might work for you as well, but I'd recommend perhaps using them both together if you have specific needs for the query. Unincluding assets, removing assets from the project. This seems counterintuitive. Surely we want to add more assets to the project, but debug assets, test assets, temporary music, all of these things need to be removed before we release the game. Default conversion settings. Now, Wwise has the feature of default conversion settings. I think it makes a lot of sense, but I don't like using them. And the reason why is if an asset is using the default conversion settings, it means that we haven't consciously thought about what its conversion settings should be. So I always like to make sure that nothing is using default conversion settings. It's okay when we're developing the game. It's okay when we're prototyping, when we're making new content. But when we get to the point where we're ready to release the title, I want to make sure everything has had human touch on it. Every asset should have had a conscious decision as to which conversion settings it's using. Asset validation. So the things we talked about before. Is dialogue stereo? Should it be? Probably not. Things like our ambiences. If we've decided to use 4-channel ambiences, are they all 4 channels, or are some of them more, are some of them less? We can check that our assets aren't broken or incorrect by using queries as well. And finally, an optimization pass. So all the things we talked about with memory, disk space, streaming, CPU, we can use queries to check that we're doing all of those things as well. And that brings us to the end. Thank you very much for taking the time here today. And I hope that the things I've talked about here serve you well in your projects. And best of luck with everything you're doing. 皆さん、ありがとうございました。そして頑張ってください。